Okay, we need to learn briefly how to wade in gravity. So, principally what this boils down to is this idea, right? You have some vector field, right? That thing maybe does something like this. You guys all good? I have a vector field flowing, right? That's the weighting portion of this. I'm thinking about the vector field as water. Okay. Now, I want to ask you a question. If I go from here to there along, say, this path, you guys see that? I am interested in, of course, in questions like, how much work does F do along, I'm going to call this path R because I'm really creative. Does that question make sense?
Yeah. It's kind of how much it does in pushing you that direction, how much is just flow doing it and not you bothering.
Yeah, perfect. You guys see this? Like, if you're going along R, is F helping you? Sure seems like it, right? Like all the flow arrows go parallel to that path, so probably. You guys see that? What if you reverse this path?
Then it's
Then
negative.
it's hurting you,
Yeah.
right?
Yeah.
It's doing anti-helpfulness. Hence, out of that, you would get a negative answer. You guys see that? Really what I'm thinking about in very reasonable ways is I'm kind of looking at a point on this curve, and I'm saying, there's some tangent vector that I'm trying to go along, right? Also, at that point, there's some kind of a blue flow vector, right? You guys see that? In this case, those are pretty similar.
Do we have to be using a dot cross product?
Probably. How do I know how much two vectors agree?
Dot cross product.
Yeah, take a dot product between them, right? Okay, so what am I going to want to do? Well, I'm going to want to, I guess I'm going to want to add some stuff, right? So what am I going to add? Yeah, I'm going to add like a force, and then I'm going to dot it with a like a delta R thing. You guys all see this? Okay, so really the thing I should maybe be thinking is I'm going to take an integral of f dotted with dr, and I'm going to do that over some path. I'm going to call that gamma. You guys see this? Because I don't really have a function r. Like I don't have a parameterization, I just have some freaking curve in the world. You guys see, like this is prior to me having equations. I'm just kind of thinking, right? Later when I have an equation, I'll have to come up with a way to actually execute that thing. But for right now, all I know is that if f helps, right, what kind of answer am I going to get?
Positive.
Positive answer. Right? And a positive answer tells you that f helps. If f doesn't help,
Hinders.
then what do you get?
Negative answer.
Yeah, that's kind of f anti-helping, right?
Impedes.
Yeah, so if f doesn't do anything to help or hinder you, what would you get?
Zero.
Okay, so if f doesn't help, you get a negative or 0, right? The interpretation of 0 would be, it's just not, yeah, so what is 0, like how do I get 0 in here?
two ways. Either there's
Oh yeah, you could either have no path, right? You could just chill at a point.
Or just be a straight line with F. Like it's not getting affected by F at all. Ours is moving and it doesn't care about F.
Okay, so this is where my weighting analogy falls down, and I have to say the gravity thing. Because I think the path that I'm going to get 0 out of means that all those dot products were 0, right? Which means that the path I'm talking about had to be what to F? Perpendicular, right? So I had to be talking about something like, what the hell? It's not even vaguely a marker. So I have to be talking about something like this, right? You guys see that? But if you walk from there to there in a river,
You're gonna be pushed.
it's really inconvenient,
Yeah.
right? But if you had a rail, right, under the water that you were attached to,
Then you just kind of.
then this is actually not helping you, but it's not hurting you either. You guys see that? Because you're not getting pushed that way. You just can't go that way anyway. You guys see that?
Wouldn't it be giving you kind of more drag though, even if you had the rail to support on? You'd be getting pushed from the side.
Yeah, assuming you had a nice frictionless rail. So the place where the nice frictionless rail happens is the gravity thing we were talking about.
Space.
You guys see that? There's not really a rail there, but there's no friction happening as the flow goes past you, right? So in the water, I have this there's this friction that's not helping me. It's not doing work against me in this sense, but it's kind of not helping my intuition. But in gravity, there's no friction as gravity kind of pushes past you, right? You guys see that? So in a gravitational field, right, this is a bunch of vectors that all point in. Right? And so what an orbit is a path around where all the vectors are perpendicular, right? Okay, you're all smiling and nodding like I'm making total sense here. But that's not the only way to do that. You guys see that? Yeah, and it's usually an ellipse. So why is it, and it's usually an ellipse, and not a circle?
Applying other vectors and.
It's because this black path that I drew, right, that's the one that's perpendicular to the stream everywhere. That's not the only way to end up with no net work, right? You could do something like this, where it helps you out a little bit and then hurts you the same amount later.
Or say you need to go somewhere and then go back the same way.
Yep, so you could go out and then come back, right? Not necessarily go out one way and come back another. That might actually cost you. You guys see this? But what a satellite's actually doing, because the probability of hitting a perfect circle is actually 0. They're all a little bit elliptical.
Wow.
So the all little bit elliptical is just, for a while gravity's helping, and then later on in that path it's going to hurt the same amount. You guys see that? Cool?
Yeah.
It's just trading kinetic energy for potential over and over and over again. Cool? All right. So with this, you should be able to do the homework for whatever the line in 18.1. So I'm going to give you the homework assignments for 17.4 and 18.1. On these ones, they're just eyeballing the sign. Don't try to calculate anything. You don't have a way to calculate.